Suppose we have this neutralization reaction where solutions of hydrochloric acid and sodium hydroxide are mixed together. So you have some initial temperature reading, and after the reaction takes place, you obtain dissociated sodium and chlorine ions in solution and H2O molecules, which gives the final temperature reading. So the heat absorbed by the solution at constant pressure is equal to the mass of the solution, and for this type of problem you'd be given the volume and molarity of each solution and also the density of the solution to work out the mass, and you multiply by the specific heat of the solution by the change in temperature. And therefore the enthalpy of the reaction is equal to the negative of the heat absorbed by the solution over the number of moles of the limiting reactant. So for example, if our limiting reactant is hydrochloric acid, we can work out the number of moles from the volume and molarity. And to get the enthalpy of the reaction, we multiply by the number of moles of the limiting reactant per mole of reaction. So here you have 1 mole of hydrochloric acid per mole of reaction. And this will give you a result in energy per mole, which we typically convert to kilojoules per mole. So if the enthalpy of reaction is negative, then we have an exothermic reaction, or if it's positive, we have an endothermic reaction. A styrofoam cup is used to mix solutions of hydrochloric acid and sodium hydroxide, and the following reaction occurs. Calculate the enthalpy of the reaction if an increase in temperature is recorded, and assume the following density and specific heat of the solution. Well, the heat absorbed by the solution at constant pressure is equal to the mass of the solution, which is the volume, multiplied by the density. And multiplied by the specific heat by the change in temperature. And to obtain a limiting reactant, we calculate the number of moles of hydrochloric acid, which is volume by molarity, and a number of moles of sodium hydroxide, so here you have a 1-to-1 ratio between the moles of hydrochloric acid and sodium hydroxide. So hydrochloric acid is the limiting reactant. And the enthalpy of the reaction is the negative of the heat absorbed by the solution over the number of moles of the limiting reactant. And in this problem, we have 1 mole of hydrochloric acid per mole of reaction. and we convert this into kilojoules. Which gives negative 64 kilojoules per mole of reaction using two significant figures. 14.1 grams of aluminium reacts with excess iron 3 oxide. Determine the amount of heat released. Well, the heat released due to the reaction is the enthalpy of the reaction. And here we have 2 moles of aluminium per mole of reaction. And then multiplying this by the number of moles of aluminium gives the heat released in the reaction. Now the number of moles of aluminium is obtained by dividing the given mass on the molar mass. So therefore, if we substitute for the number of moles, we determine the heat released by the reaction. Using 3 significant figures.